Hello students. Till now we have studied about the phenomena of electromagnetic induction a lot. Now I am going to introduce a new term called self induction. So here in this video we are going to study about self induction. For understanding it, let us consider a coil and having a current flowing through it. So we have a coil through which current is flowing, and we know that whenever we have a current carrying coil, it causes a magnetic flux through the coil itself. Because of the flow of current, there exists a magnetic flux linked with that coil. Now if the current is steady, that magnetic flux linked with the coil remains unchanged. But what if the strength of current is changing? Means the current that is passing through the coil, that is flowing through the coil, is keep on changing. Then in that case the linked magnetic flux through the coil also changes, and since there is a change in magnetic flux, then according to the phenomena of electromagnetic induction, an opposing EMF is induced in the coil. So this EMF that is caused by the change in magnetic flux linked with the coil itself is called self induced EMF or back EMF, and this phenomena is known as self induction. So if we see, then self induction is actually a kind of electromagnetic induction only, in which a current carrying coil having a magnetic flux linked with it undergoes a change in current through it, and because of that change in current, the magnetic flux linked with that coil also changes. And since the magnetic flux changes, an opposing EMF is induced in that coil, and we call that induced EMF as self induced EMF or back EMF, and this phenomena is known as self induction. So let us define the phenomena self induction. So self induction is the phenomena of production of induced EMF, the phenomena of production of induced EMF in a coil when a changing current passes through that coil or passes through it. We can also write the phenomena as phenomena of production of induced EMF. Means we have a coil having current flowing through it. Now if the strength of current changes, magnetic flux linked with the coil also changes, and because of the change in magnetic flux, an induced EMF set up in the coil, and this induced EMF is known as self induced EMF or back EMF, and this whole phenomena is called self induction, right? So whenever we have a current carrying coil, if the strength of the current changes, the magnetic flux also change, the magnetic flux that is linked with the coil also change, and because of that change in magnetic flux, as we have studied in electromagnetic induction, an induced EMF set up in the coil, and since that induced EMF is only because of the same coil, means that coil is inducing EMF in it only, in itself, that's why it is called self induced EMF or back EMF. Okay, and this whole phenomena of production of induced EMF in that coil is called self induction. This whole phenomena of self induction can be understood in a better way by taking an example of a coil connected with a battery. So I am considering a coil connected to a battery through a switch, okay, through a tapping switch. So here in the diagram, first I am talking about the diagram A. I have a coil connected to a battery and a switch. Now I am closing this switch. First I am saying the closing switch. Okay, when I close the switch, circuit get completed and current start flowing in the circuit. जैसे ही हम इस की को क्लोज करेंगे या स्विच को क्लोज करेंगे, ये सर्किट कंप्लीट हो जाएगा एंड बिकॉज ऑफ दैट current start flowing through the circuit, and we know that the direction of current is from positive terminal to negative terminal of the battery. But as we close the switch, the current increases in the circuit, and because of that a magnetic flux through this coil also increases, right? Initially when this switch was open, there was no current, no magnetic flux. So initially when this switch was not closed, magnetic flux was zero, there was no magnetic flux. But when we close this switch, current start flowing, and because of that, as the current approaches to its maximum value, this magnetic flux also try to approach at its maximum. Okay, so as we close the switch, current starts flowing through the circuit, and as the current increases, magnetic flux also increases from 0 to its maximum value. Now since there is a change in magnetic flux, this 0 to 5 max shows the change in magnetic flux throughout the process. Because of this change, an induced EMF set up here. Now this induced EMF is called self-induced EMF or back EMF, and because of that EMF, because of the phenomena of induction, an induced current start flowing in the circuit. And we know that induced current always flow in a direction to oppose its cause, राइट. सो इंड्यूस्ड करंट का डायरेक्शन हमेशा अपने कॉज को अपोज करता है. सिंस द कॉज फॉर इंड्यूस्ड करंट इज इंक्रीमेंट ऑफ मैग्नेटिक फ्लक्स, मैग्नेटिक फ्लक्स का बढ़ना या करंट का बढ़ना इज द कॉज बिहाइंड द इंड्यूस्ड करंट. सो दिस टाइम इंड्यूस्ड करंट हैज डायरेक्शन लाइक it try to oppose that increment, so it will flow in an opposite direction to the battery current. That means this will be the direction of induced current because it try to oppose its cause, and its cause is the battery current. battery current की वजह से ये induced current हमें मिला है, and according to Lenz's law this induced current try to oppose its cause, that's why it will oppose the direction of battery current, right? Now come to the second diagram. In case B, here I am trying to open the switch. That means initially the circuit was closed, and because of that current was already flowing in the circuit. Initially की close थी and इस पूरे circuit में current already flow हो रहा था, and now I am trying to open the switch. Okay, as soon as I open this switch, the current start decreasing, and because of that decrease in current, magnetic flux through the coil also decrease from its maximum value to its zero value. Means initially there was current flowing in the circuit, so initially phi was actually at its maximum value, but as soon as I opened the switch, current starts decreasing, and because of that the value of magnetic flux also start decreasing, and finally it comes to 0. So it starts decreasing from maximum to 0, and because of this change in magnetic flux, an induced current starts flowing in the circuit. Induced EMF set up there, and because of that induced current starts flowing, but induced current will try to oppose the reason because of which it is induced. So यहाँ current का induce होने का reason है this current only, and we are opening the switch. So when we opening the switch, current is decreasing in the circuit. So this time induced current will be in the direction so that it can अपोज दैट डिक्रीज करंट, बिकॉज सर्किट में करंट डिक्रीज हो रहा है जिसकी वजह से हमें इंड्यूस्ड करंट मिला है, तो इंड्यूस्ड करंट का डायरेक्शन इस अकॉर्डिंग होना चाहिए कि वो बैटरी करंट के डिक्रीज को अपोज करे। सो बैटरी करंट के डिक्रीज को अपोज करने का मतलब है कि वो बैटरी करंट को सपोर्ट करे, दैट मीन्स उसको इंक्रीज करे। डिक्रीज को अपोज करना, दैट मीन्स उसको इंक्रीज करना। सो दिस टाइम the induced current will be in same direction as of battery current, so that it can increase the battery current as it is decreasing, क्योंकि battery current decrease हो रहा है and that is the reason for this induced current, so it try to oppose that decrease, and to oppose that decrease it try to be in the same direction of current. So this is how the phenomena of self induction work. Okay, now by observing the whole phenomena of self induction, what we conclude that at any instant, whenever we can pick any instant, then at that point, at the certain time, the magnetic flux linked with the coil is actually proportional to the current. It only depends on the current in that coil. So we can write, at any instant this magnetic flux depends on I, or directly proportional to the current through the coil. Okay, now if we remove this proportionality constant, then there must be some अगर हम ये proportionality sign हटाएंगे, then there must be some proportionality constant, let it be capital L, then we get phi is equal to Li. Phi depends on I, and when we remove proportionality sign, we get the value phi is equal to Li, where L is a constant, L is a proportionality constant for a particular coil and is called self inductance of that coil, or sometimes it is also known as coefficient of self induction. So we know L by the name self inductance or coefficient of self induction of that coil. जिस coil की हम बात कर रहे हैं, this is the self inductance of that coil or coefficient of self induction for that particular coil. अगर हम coil को change कर देंगे, the value for self inductance will be different. Okay, so जिस भी coil को हम लेंगे उसके लिए एक separate value हमें self inductance का या coefficient of self induction का मिलेगा. Now we know that whenever this current change, since phi depends on current, whenever this current change, magnetic flux will also change, and because of the change of magnetic flux, an induced EMF will be set up in the coil, and that EMF can be given by using laws of electromagnetic induction. So that induced EMF epsilon can be given by the formula minus d phi over dt, and we know that phi is equal to Li. So by substituting this value for phi, we can find that epsilon is equal to minus L di over dt. Okay, so this is the value for induced EMF in that coil. So we can define self inductance L by using this relation. Let's see how we can define self inductance by using this formula. So the formula is induced EMF epsilon is equal to minus L di over dt, where phi is equal to Li. Right, हमने phi को Li substitute किया, तब हमें ये relation मिला है. So now to define self inductance, I am assuming that current is equal to 1, then in that case we get phi is equal to L. If I is equal to 1, then phi is equal to L. So how can we define self inductance? It can be defined as the numerically equal value of magnetic flux linked with the coil when a unit current flows through it. So we can say that this self inductance will be numerically equal to phi if the coil has 1 ampere of current flowing through it. We can write it as self inductance of a coil is numerically equal to 1 or equal to magnetic flux. This self inductance is equal to magnetic flux when unit current flows through that coil. So अगर coil में से 1 एम्पियर या यूनिट करंट फ्लो हो रहा है, then in that case the value of self inductance will be equal to the magnetic flux phi linked with that coil. This is how we can define self induction, coefficient of self induction or self inductance. Also from this equation we can define self inductance as, from this equation we have to assume that if di over dt is equal to 1, then induced EMF epsilon will be minus L. So we can also define L by using this first equation. If di over dt is equal to 1, then epsilon is equal to minus L. Then in that case the self inductance of the coil can be defined as the induced EMF set up in the coil. This self inductance is equal to the induced EMF set up in the coil due to a unit rate of change of current through it. Okay, so when this rate of change of current is unity, then jitna induced EMF set up hoga, that will be the value for self inductance. So we can also write this definition as, the self inductance of a coil may be defined as the induced EMF set up in a coil due to a unit rate of change of current through it. So if the rate of change of current from a coil is unity, the induced EMF will be actually equal to the self inductance of that coil. Okay, so this is the definition for self inductance or coefficient of self induction. Now after definition we are going to see its units. What are the SI unit for the value capital L? So from this relation epsilon is equal to minus L di over dt, we can get L as minus epsilon upon di over dt. So this is the formula for self inductance, and for its units we have to write the units of epsilon, di and dt. So SI unit of self inductance will be, for epsilon it is 1 volt, for di over dt it is 1 ampere second inverse. So its unit will be 1 volt second ampere inverse, or we also known it as 1 Henry. We have to represent it by capital H. Okay, so SI unit of self inductance is 1 volt second ampere inverse, and in SI system we call it as Henry. So the self inductance has SI unit Henry, and we can define 1 Henry as, the self inductance of a coil can be defined as 1 Henry if an induced EMF of 1 volt is set up in that coil when current in it is changing at the rate of 1 ampere per second. So if in a coil there is an induced EMF set up of magnitude 1 volt, and at that time the rate of change of current is 1 ampere per second, then in that case the value for inductance, for self inductance, will be 1 Henry. So we can define 1 Henry as the self inductance of a coil if induced EMF of 1 volt is set up in that coil when current is changing at the rate of 1 ampere per second. So this is the definition for 1 Henry. That value of self inductance जब आपके पास induced EMF 1 volt का setup हो in the coil by changing its current at the rate of 1 ampere per second is called the self inductance, the unity self inductance, or is called 1 Henry. We can also find the dimensions of self inductance. Let's see what are the dimensions of self inductance. Now we know that L is equal to phi upon I, and phi is equal to B A upon I, and B is equal to F upon Q V sine theta into A upon I. So by taking the dimensions of all the quantities here on right side, we can find the dimensions of self inductance L. Let's see what are the dimensions. For force it is ml t minus 2, for area it is L2, for charge it is coulomb, or coulomb ko we can write as at. For velocity it is lt minus 1, and for current it is again ampere. So on solving this we get ml2 t minus 2, okay, t minus 2 and a2. So the final answer that we get for the dimensions of self inductance is ml2 t minus 2 a minus 2. ml2 t minus 2 a minus 2 is the dimensions of self inductance or coefficient of self induction. L के dimensions होंगे हमारे पास ml2 t minus 2 a minus 2. So that was all about the phenomena of self induction, self inductance, or coefficient of self induction, its SI unit and its dimension. Okay, we can define self inductance as the induced EMF set up in a coil due to a unit rate of change of current through it, and we can define 1 Henry as the amount of self inductance of a coil if induced EMF of 1 volt is set up in the coil when current is changing at the rate of 1 ampere per second. So that is all about the self induction. Now in the next video we will be studying self inductance for a long solenoid. Means we will be calculating an expression for the value of capital L if there is a long solenoid. Okay, for that video stay tuned and keep studying. Thank you.